So in this session we are going to discuss about extraction of another important metal, and that is what aluminium. Student, if you'll see, before moving to the extraction part, we know that aluminium is very important element and it is the third most abundant metal onto the earth surface. So if you'll check the uses of aluminium metal, it is used to prepare foils because of high malleability. It is used to make utensils, aluminium paints, and also it is used to make alloys like duralumin. So because of all these uses, aluminium is very important for us, and it is very important to know about the science of extraction of aluminium. We all know that for extraction of any metal, we require its appropriate minerals. So if you will check these minerals over here, is the most important minerals from where the metal is extracted, that is ore of aluminium, is bauxite. So it is important to know, for us to know the formula of the bauxite. Bauxite is written as Al2.2H2O. If you will see, this 2H2O is water of crystallization, and the value of water of crystallization is 2. It is called as dihydrate. So in MCQs, if they will ask the formula of bauxite, you are supposed to write Al2O3.2H2O. Please remember, it is dihydrated. Another minerals like cryolite. Cryolite is sodium aluminium fluoride. Corundum is the next mineral. This is Al2O3. If you compare with the bauxite, bauxite is the hydrated mineral, that is Al2O3.2H2O, but the corundum is what? Al2O3. Das4 is the another mineral of aluminium, and the formula is Al2O3.H2O, very much similar to bauxite. But if you see, the water of crystallization in the bauxite is what? 2H2O, but in Das4 it is what? 1H2O. So bauxite, if it is said that dihydrated, then Das4 will be referred as what? Monohydrated. Next is China clay. China clay is a type of mineral which is aluminium silicate. If you will see, this part is oxide of aluminium, and this is what? Silica. It's a hydrated aluminosilicate mineral. So out of all these minerals, the most efficiently from where the metals, the aluminium, can be extracted profitably is what? Bauxite. So bauxite is selected for the extraction of aluminium. Now for metallurgy, we all know that the very first step is what? Concentration. Now in concentration, we are removing what? Impurities, that is also referred as what? Gangue, and this impurities is removed by various methods. For aluminium, mostly we use what? Leaching, that we have done in the first lecture only. So the process also depends upon the type of the bauxite. We use Bayer's process, and the leaching reagent that we are using is what? Caustic soda. It's hot and concentrated solution of sodium hydroxide, and it is applied for red bauxite. Here the red bauxite is indicating types of bauxite. Hall's process is also used here. The leaching agent which is used is what? Sodium carbonate, and it is again applicable for red bauxite. Serpex process is used for white bauxite. So you all can say that there are two different type of bauxite, that is red bauxite and white bauxite. So for red bauxite, we can use Bayer's reagent, Bayer's process, by using sodium hydroxide as a Bayer's reagent, and here the Hall's process, we are using what? Sodium carbonate, and for Serpex process we use what? White bauxite. In red bauxite, the impurity which is present is what? Iron. and in white bauxite the impurity which is present is what silica impurities. So these are the methods of concentration, and after doing concentration, the step 2, if you will check, it is referred as what extraction. Now we all know that, student, generally in extraction we are converting ore, that is metal compound, or you can say concentrated ore, to its oxide. But here if you will see, we are not converting ore into its oxide. The reason is that if you check the formula of bauxite, it is Al2O3.2H2. So here the aluminium metal is associated in the form of what? Oxygen. It is already oxide. So we don't take Al2O3 and again we don't convert to what? Oxide. So if this step is not carried out, the next step is what? Conversion of metal oxide into free metal. We know that in extraction we are converting metal compound to its oxide, and from there metal oxide we convert to what? Metal. Since the ore is already form of oxide, so it does not require the A step, it requires the step B, which involve conversion of metal oxide into what? Free metal. So this step is also referred as what? Reduction, because it involves removal of oxygen. So for aluminium extraction, the type of reduction which is used is electrometallurgy. Student, we know that electrometallurgy is applied for highly reactive metals, the metal which forms what? Stable oxide. So electrometallurgy, which is the method of reduction of bauxite, involve electrolysis of fused alumina. Means we are doing electrolysis of fused, means what? Here we take molten form of alumina. This process is done by Hall and Herold's process. If you will see Hall and Herold's process, so it is involving electrolysis of fused or molten alumina. In this case, if you will see, we require electrolytic bath. If you will check this diagram, since we know that for electrolysis we require electrolytic cell and different conducting materials which are connected to opposite terminal of the battery, one which is referred as anode and cathode. In this electrolytic cell, if you will see, this is ion tank, and the inner part of the tank is coated with what? Graphite. Now we all know that graphite is the allotropic form of carbon. So this inner portion of this electrolytic cell is coated with carbon, and it is acting as one of the electrode, and it is connected to negative terminal, so it is acting like what? Cathode. So please remember, graphite is used to make cathode. Another electrode, if you see, these all cylindrical rods which is inserted into this electrolytic bath is again made up of what? Graphite, but this time it is connected to positive terminal of the battery, and that's why we referred as what? Anode. This anode and cathode is responsible for different redox reaction which is occurring into them. Inside this electrolytic cell, we take molten alumina. This is the purified form of the bauxite. This bauxite is converted to what? Alumina, and the formula of the alumina is what? Al2O3, which is obtained in Weir's and Hall's process. So we are doing electrolysis of alumina. We require this alumina in molten form or fused form. Along with this alumina, we are mixing Na3Alf6, which is called as cryolite, and also CaF2, which is referred as what? Fluorspar. We are taking this mixture, and at the end of the electrolysis, if you will see, 99% pure aluminium is obtained at cathode. Now, if you will see, this is basically electrolysis of alumina. but along with alumina we are adding two other electrolytes. One which is referred as cryolite, that is Na3Al6, and another one which is referred as what? Fluorspar. So very important question which comes, student, over here. Why we are adding these two other electrolyte along with the molten alumina? So the answer is that there are two difficulties we are facing in this process. The conductivity of alumina is very less, and to melt alumina a very high temperature is required. So we can get rid from this two difficulty if we will add these electrolytes. Na3Al6 and CaF2 when it is added. So there are two advantages. The very first, it reduces the melting point of the metal, and second, it increases the electrical conductance of the solution. If we are not mixing these electrolytes, then the reaction needs a very high temperature to operate, that is about 1800 degrees Celsius. On mixing these two electrolytes, the temperature get lowered from 1800 degrees Celsius to 1000 degrees Celsius. That is the reason why we are mixing these two electrolytes. Now, let's learn in detail about Hall and Herold's process of reduction. Now, we know that since it involves electrolysis of molten alumina, so it involves electrolytic cell or electrolytic bath. This electrolytic cell is consisting of what? Iron tank. You can see it's a rectangular box which is made up of what? Iron. It's iron tank, and the inner side of this iron tank is coated with what? Graphite. That is what? Carbon. Now this coating of graphite to the inner side of the tank is connected to negative terminal of the battery, and it is acting as what? Cathode. Other electrode, that is anode, is made up of what? Graphite. So please remember, cathode and anode, both these electrodes are made up of what? Graphite, as the graphite is the good conductor of what? Electricity. Now in this tank we are taking a mixture of three different electrolytes. The major electrolyte that we are taking over here, if you see their percentage: alumina, that is Al2O3, that is 2 to 8%. Cryolite, that is Na3Al6, is taken 80 to 85%. Aluminium fluoride, that is 5 to 7%, and fluorspar. This fluorspar is also called as calcium fluoride, and the percentage of calcium fluoride is 5 to 7%. Now these all are the supporting electrolyte which is added to increase the conductivity of alumina and also to reduce the melting point of the alumina. Now if you'll see these two, that is electrodes which are made up of what? Graphite. They are connected to the opposite terminal and both are made up of same material. Now let us understand what type of reaction is occurring in this electrolytic cell. Student, we are adding this electrolyte alumina, that is Al2O3, cryolite, aluminium fluoride and calcium fluoride. So when they are taken into the molten state, they produces their respective ions. Like cryolite, that sodium aluminium fluoride, at this high temperature or in the molten state, it produces ions of sodium, aluminium and fluorine, or you can break in this way also. If it breaks, what it produces? It gives sodium fluoride and aluminium fluoride. So this sodium fluoride and aluminium fluoride, if you see, the common element which is present is what? Fluorine. That is fluoride. So it is a source of what? Fluoride. From here, aluminium fluoride, it split to give ion of aluminium and fluorine, that is AlF3 and F minus. Now this is the cation which is produced by aluminum fluoride, and this is the anion. So the cation is Al3 plus, there is aluminum ion, and the anion is fluoride ion. Now these cations and anions which are present into this electrolytic cell, they get discharged to their respective electrodes. When we talk about cathode, now we know that cathode have negative charge and it is responsible for reduction. Being negative charge, it is going to attract positively charged electrolytes. So if you see the positively charged ion which is present is what, Al3 plus. Check the charge of Al3 plus, and cathode is responsible for what, reduction. So how many electrons are required to reduce one ion of Al3 plus? Yes, it is 3 electrons. So aluminium 3 plus gains 3 electron from graphite cathode and it gets reduced to give aluminium metal. Now student, please remember, since the reaction temperature is very high, it is above the melting point of the aluminium. So the aluminium which is deposited onto this inner lining of the electrolytic cell, that is at cathode, is obtained into the molten form. Now let's check the next reaction. This all molten form of aluminium gets removed from one outlet which is referred as what, drain plug. At anode what happens? Now the charge of the anode is opposite of cathode, that is positive, and the reaction which takes place at anode is oxidation. Being positively charged electrode, anode is going to attract what? Negatively charged radical. Now the negatively charged ion over here is what? F minus, that is fluoride, and it should get oxidized as at anode the oxidation reaction takes place. So during oxidation there has to be loss of electron. There is one negative charge, so it has one extra electron, so it is going to lose one electron. If it loses one electron, so it forms atom of fluorine. That is, you can check the change in the oxidation state also from -1 to 0. This is completely oxidation. But fluorine is a halogen and all halogen is what, diatomic. So one fluorine combines with another fluorine, it forms fluorine gas. So overall there is a loss of what, 2 electrons. Now this fluorine is the most powerful oxidizing agent, so it immediately breaks or decomposes this alumina. This fluorine is highly reactive. It breaks this alumina and it forms, if you will see, it forms aluminium fluoride, and there is a liberation of what, oxygen gas atom. Please remember, there is a liberation of oxygen gas at anode. Now, if you see this oxygen gas which is liberated, student, it starts reacting with the anode because the anode is made up of graphite and there is the carbon content. This carbon at this high temperature, and this oxygen is very reactive element, it reacts and it produces oxides of carbon. So if you will see this, the oxygen which is liberated at anode reacts with carbon of the anode and it produces carbon monoxide and carbon dioxide. During this process, if you will see, the mass of anode decreases, or you can say the anode is slowly eaten up by liberated oxygen onto its surface. So it is very important for us to replace anode time to time. It is approximately, we can say, for production of 1 kg of aluminium, half kg of anode is what consumed. If you see the reaction, the oxygen which is liberated at anode, this oxygen, when it comes in the contact with the surface of the anode, which is made up of carbon. At very high temperature, it immediately combines and it forms carbon monoxide. This carbon monoxide again get oxidized to give what? Carbon dioxide. So during this process, what happened? The mass, or you can see the thickness of this electrode get decomposed, or it diminishes in the mass, and if this plate is not changed, the process will stop. At the end of the process, gradually you can see there is a collection of molten aluminium at the lower part of this tank, and from this drain plug it is taken out. We get around 99% of aluminium into this, and I told you this 1 kg of aluminium production consumes 0.5 kilogram of carbon from the anode. Now the next step is what, student? It's refining. The aluminium which is obtained from the previous step is not 100% pure, so it is need to refine it, as the aluminium which is obtained is a crude aluminium. So for refining, the process that we use is what? Hoops process. Again, it involves what? Electrolysis. So for this, the apparatus that we are using is consisting of 3 molten or fused layers. Say for example, if this is electrolytic cell, then it is consisting of 3 layers. The lowermost layer, or you can say the layer which is forming the part of this bottom of the electrolytic cell, is consisting of impure aluminium. Please remember, from the previous step, all impure aluminium is poured into this electrolytic cell. This impure aluminium itself is connected to positive terminal of the battery, and it is acting as what? Anode. So here we are not using any other electrode, because aluminium itself is acting as what? Anode. The middle layer, or the second layer, you can say, it is consisting of mixture of certain electrolytes like sodium aluminium fluoride, which is cryolite, and barium fluoride. So this electrolyte is added for the conduction of ions, and the uppermost layer, if you will see, the top layer is obtained because of the reduction of aluminium, which migrates from impure aluminium, that is from bottom layer to top layer. So at top layer, the aluminium which is obtained is the highest or highly pure form of the aluminium, and this pure form of the aluminium is acting as what? Cathode. Please remember, the bottom layer is impure aluminium and the top layer is what? Pure aluminium. The impure aluminium is acting as anode and the pure aluminium is acting as cathode. From here, if you will see, during the process, aluminium 3 plus ions from the bottom layer migrates and it gets deposited into what? Top layer. So what happens? This quantity of the top layer goes on increasing and the quantity of this bottom layer goes on decreasing. This is how we refine what? Aluminium metal. We discuss the very important use of aluminium metal in a process called smelting. Now we all know that, students, smelting is a process of reduction where we are reducing metal oxide by using some suitable reducing agent. So for smelting of certain metal, we use what? Aluminium metal, as aluminium metal is very reactive metal. There is a process which is referred as goldsmith aluminothermite process. So in aluminothermite process, the aluminium metal is used as what? Reducing agent. If you will see, in reduction, what we do? We convert metal oxide to metal means we have to cut this part. I mean, we have to remove this oxide part, and removal of oxygen in science is referred as what? Reduction. So for removal of this oxide from the metal oxide part, we mix aluminium metal, which is highly reactive. So when this aluminium powder is mixed with metal oxide and it is heated, then this oxygen leaves the previous metal and it gets combined with what? Aluminium metal. This is how we get metal oxide from metal. So here aluminium is acting as reducing agent. If you will see, this method is used for the extraction of the metals like chromium, iron metal, manganese and silicon. In this case, student, let us see some example. Suppose if we have to reduce what? Chromium oxide. Generally, chromium extraction involves extraction of chromium from chromium oxide. Now, in metallurgy, we don't require chromium oxide, we require only chromium. So, with this powdered form of chromium oxide, we mix powdered form of aluminium metal. So, when this aluminium metal is mixed with chromium oxide and it is heated, then this aluminium being more reactive than chromium, it displaces chromium from its oxide. So the product that we get is what? Since this oxygen is removed from Cr2O3 and it gets combined with what? Aluminium. So it forms aluminium oxide and we are getting what? Chromium. Now if you will check the enthalpy change of this reaction. So enthalpy change of this reaction is what? Negative. That clearly indicates the reaction is what? Highly exothermic. Since it is exothermic and the heat which is liberated is enough to melt the metal which is reduced. So chromium metal which is obtained in this process is what? In the liquid state. So we are getting reduced metal in the molten form. And we are getting byproduct as what? Aluminium oxide. Now if you will check the oxidation state of aluminium over here. So aluminium metal powder, when it is added, it is the elementary form of aluminium and the oxidation state is what? 0. And aluminium gets converted to aluminium oxide where the oxidation state is what? +3. So if you will check the change in the oxidation state, it is from 0 to +3. So there is increase in charge. So this process is oxidation half reaction. So can I say aluminium is undergoing oxidation reaction? And that's why aluminium is acting as what? Reducing agent. And chromium, if you check the charge of the chromium is decreasing. So the chromium metal is getting reduced to metallic chromium, and because of highly exothermic reaction, this chromium is obtained in molten form. This is also used in some of the reactions, student. For example, a reduction of iron metal, the same process takes place. To this iron oxide, the powdered aluminium is added, and this aluminium is able to displace iron. When aluminium metal powder is heated with this, it displaces iron. Again, the reaction is highly exothermic and the iron metal is obtained in the molten form. Now this process is used to fill the cracks in the railway tracks. This is also called as thermite welding. The second reaction is responsible for the thermite welding. We are doing the welding of iron metal by this. More reaction, if you will see, aluminium metal, it is also used to reduce manganese oxide. This aluminium being more reactive than the manganese, when this aluminium metal powder is heated with this, when this aluminium displaces manganese, and we are getting manganese in the molten form as the delta H, that is negative, which indicates it is highly exothermic reaction. So in all these processes, even for silicon oxide, which is non-metallic oxide, that is, you can say it's a metalloid, the aluminium metal powder is able to displace silicon, and again we are getting the molten form. So all this thermite process here, the aluminium is acting as reducing agent. So it is one of the important use in the smelting process. For doing extraction of copper metal, student, we should aware about the minerals and the ores of the copper. So if you'll see the list which I'm giving you is consisting of some important minerals of copper metal. The very first is what copper pyrite, which is to be considered as the chief ore of the copper metal, and the formula of the copper pyrite is CuFeS2. So it is copper iron sulfide. Please remember the formula, it's CuFeS2. Another minerals, if you see, it's malachite. The formula of the malachite is CuCO3.CuOH twice. So this part is what copper carbonate, and this is copper hydroxide. Now we all know that the hydroxide of the metal is what basic in nature. So presence of this hydroxide actually indicates what basic nature of this. So it is also called as basic copper carbonate. Azurite, if you check the formula, again it is basic copper carbonate, but there is a change in the composition. Malachite is CuCO3.CuOH twice, and azurite is 2CuCO3.CuOH twice. Very similar formula, but it contains 2 moles of CuCO3. Another is what cuprite, and this cuprite is copper 1 oxide, which is also referred as cuprous oxide, as the charge of the copper is 1 plus. Copper glance is again another mineral which is referred as copper sulfide. So if you will see, again the charge of copper is copper 1 plus, it is copper sulfide. So if you just make the list of the minerals of copper, it is copper pyrite, malachite, azurite, cuprite and copper glance. Generally, the copper metal is extracted from its chief ore, that is copper pyrite. So CuFeS2, which is copper pyrite, is the ore taken for extraction of copper metals. Now if you will see the metallurgy, we know that the very first step which involved is what? Concentration. Now concentration involves removal of gangue particle, or you can say earthy impurities, but that method which is applied to remove gangue particle totally depends upon the type of the ore. Student, here we have taken copper pyrite, which is sulfide ore, and we will know that for the sulfide ore the process which is used is what? Froth flotation process. As copper pyrite is sulfide ore and it is non-wettable towards water. So we add oil and water in the and we do froth flotation process. Now the detail of the froth flotation process we have done in lecture 1. So here we will just say this concentration method is applied, which is what? Froth flotation process. After doing concentration, the next step is what? Extraction. Now basically what we do in extraction, we are converting a metal compound that is concentrated ore to its metal oxide. So during this conversion we can do 2 processes. One is what? Roasting, and one is what? Calcination. Now we know that when to apply roasting and calcination. Student, roasting is applied if the metal is associated with sulfur, that is sulfide ore, and calcination is applied if the metal is present in the form of carbonate. The ore that we have taken is copper pyrite, which is sulfide ore. So the best method for conversion from metal compound to metal oxide is what? Roasting. We are doing conversion of ore into its oxide, and the method that we are using is what? Roasting, because it is sulfide ore. Now we know that what we do in roasting, we are converting metal sulfide into its oxide. So the powdered form of the ore is heated in the excess of air, so it forms oxides of copper as well as what? Oxide of iron. If this powdered form of ore is heated in the limited supply, so instead of forming oxide, it forms its corresponding sulfide. Say for example, the CuFeS2, it gets converted to Cu2S. This is called as copper 1 plus sulfide, and this is FeS. It is Fe2 plus sulfide. During this process, the byproduct which is obtained, the waste product which is obtained is sulfur dioxide gas. Since it is a gaseous product, so it is taken out from the mixture. So, in the first step of the roasting, what we are getting, this copper pyrite gets converted to copper 1 sulfide and the iron 2 sulfide. Student, please remember, iron 2 sulfide is acting as what? Gang in this case. Now, to remove this gang, since it is consisting of another impurities as arsenic and antimony. So, during roasting, the arsenic and antimony, they forms their volatile oxides and they can be easily removed as what? Volatile impurities in the form of their respective oxides. See, arsenic and antimony can be removed in the form of their volatile oxides. So, in this process, what we are doing, copper pyrite is converting to what? Copper sulfide, and this copper sulfide is associated with what? Impurities, that is iron sulfide. So, now the question is that how to remove iron sulfide? If you will see, iron sulfide impurities can be removed to the next step, that is referred as what? Reduction. Generally, in this process, what we do, we are reducing metal oxide to metal by adding some suitable reagent, which is referred as what? Reducing agent, and this process is carried out at very high temperature. That's why the method of reduction that we are using is called pyrometallurgy. During pyrometallurgy, we are adding reducing agent and we are heating it, and there is another term for this is what? Smelting. Now, roasted ore, which is obtained in the first step, is mixed with coke. Now, powdered form of coke, and it is also mixed with what? Sand. Please remember this mixture. Roasted ore is mixed with coke and sand. So, if you'll see, FeS, which is the one of the product obtained during roasting process, is acting as what? Impurities. With excess of air, student, it gets converted to what? Its corresponding oxide. So FeS gets converted to FeO, and again there is a loss of sulfur dioxide. This FeO, if you will see, it is basic in nature. Now we know that to remove impurities, we add flux, but the type of the flux which is added is depending upon the nature of the metal oxide. So if it is basic impurities, so to remove this we add acidic flux. So here the sand, the component of sand is what? SiO2, that is silicon dioxide. It is acting as what? Acidic flux. So this basic flux FeO get combines with the acidic flux SiO2 and it forms easily fusible mass. This easily fusible mass is what? Iron silicate, which is referred as what? Slag. We know that, student, gangue plus flux forms easily molten or easily fusible mass, which is referred as what? Slag. This slag is having lower density and it is forming the upper layer of the mixture, if you will see. Can you see this? This is the slag which is obtained during this process, which is consisting of all impurities, and the lower part is consisting of molten metal. Along with this molten metal, this is consisting of sulfides of copper 1 plus, Fe2 plus, coke and sand. This entire mixture is referred as copper matte. So it is very important to learn, student. Copper matte, the constituent is what? Sulfides of copper 1 plus, Fe2 plus, coke and sand.
Copper matte is the impure form of the copper metal. To get pure form of the copper metal, we do the next process that is referred as what? Bessemerization. In Bessemerization, student, the matte which is obtained from the previous step is transferred into Bessemer converter. It is a type of blast furnace which involves oxidation of copper 1 sulfide to copper oxide, and at the same time it also involves the reduction of copper 1 oxide to copper metal. So Bessemer converter, if you will see, the function of this can be done by passing blast of hot air. So here this air is acting as what? Oxidizing agent to the mixture which is present into what? Copper metal. If you will see this, it's a type of furnace, student, and which is egg shaped furnace, and it is totally made up of what? Steel, and the inner lining of this, if you will see, it is consisting of fire clay bricks. This is the part which is indicating we have transferred what? Copper metal, and from this inlet we are passing what? Hot air. So this hot air, when it comes in the contact of this metal, it causes what? Oxidation. So the reaction which take place into Bessemer converter, if you will see, this metal is consisting of copper 1 sulfide, and from this inlet when we pass hot air, which is constituted with what? Oxygen. So this oxygen causes oxidation of copper 1 metal and sulfur. So there are two products obtained. One is copper 1 sulfide get oxidized by this hot air to form copper 1 oxide, and the impurities which is associated with the sulfur, it forms a gaseous product which get releases from the top of the Bessemer converter. So there is removal of sulfur as an impurity in the form of sulfur dioxide gas, and this entire copper 1 sulfide which was present in the matte gets converted to what? Copper 1 oxide. But please remember, student, we don't want copper 1 oxide, we require what? Copper metal. So we have to remove this oxygen. Generally this involves what? Reduction. Generally, to remove oxygen, we add what? Different chemical reagents, but in this case, there is no need to add any external reducing agent. In case of Bessemerization, there is oxidation take place, and the reduction does not require any reducing agent. So this we can refer it as what? Auto reduction. Auto reduction is what? Self reduction. So how the self reduction is carried out within this converter? This copper 1 oxide which is formed is combined with the remaining copper 1 sulfide, if you will see. Copper 1 oxide which is formed is combining with the remaining copper 1 sulfide, and this remaining copper 1 sulfide helps in reducing copper 1 oxide. So copper 1 oxide oxygen gets removed and it gets combined with the sulfur of copper 1 sulfide. So when this sulfur and oxygen combines, it releases what? Sulfur dioxide gas, which is obtained in this case is what? Reduced product of copper 1 oxide, and here copper 1 sulfide is acting as what? Reducing agent. Since reducing agent is present within the mixture, so there is no need to add any external reducing agent. That's why this process is also referred as auto reduction or self reduction. Please remember, student, copper 1 sulfide which is present in the mixture act as reducing agent. So it reduces copper 1 oxide to copper metal which is present in the molten form, and sulfur dioxide gas is the waste product which is obtained over here. Now this mixture is poured into sand molds, and if it is kept for a longer period of time, since it releases what? Sulfur dioxide gas, as the sulfur dioxide gas is released from this molten metal, it forms blister onto the surface of the metal. Because of the formation of the blister onto the surface of the metal, this copper which is obtained from the Bessemer converter is also referred as blister copper. This blister copper is about 99% pure, and if you see the physical appearance is like this. Now, how to purify this metal? So next step is what refining of the copper metal. The blister copper which is obtained is consisting of some impurities, and sometimes it is consisting of what? Valuable impurities. So the method of refining that we are using over here is what? Electrolytic refining. The valuable impurities which is present is what? Silver metal and the gold metal in the very small proportion. For electrolytic refining, we require electrolytic cell. If you will see, in this case, anode and cathode both is made up of copper, but anode is made up of impure copper, that is blister copper, and cathode is consisting of a thin strip of the pure metal. So please remember, student, anode and cathode both is made up of same metal. Only the difference is that anode is made up of impure copper, that is blister copper, and the cathode is made up of pure copper. This electrolyte should contain the ions of the same metal. So the electrolyte that we are using is what? Copper sulfate. It's CuSO4. So it is consisting of copper 2 plus ions. When the process starts, all the ions of copper 2 plus from the electrolytic solution will get reduced and deposited onto the surface of cathode. So the concentration of copper 2 plus ion decreases inside the solution. As the concentration of copper 2 plus ion decreases to a certain limit, the anode, which is made up of copper metal, start oxidizing and producing its own ions. So at the end of the process, because of the deposition of the copper metal, this cathode becomes thicker, and because of the decomposition of the anode, this mass of the anode decreases. At the end, you will find the impurities, and these impurities may be consisting of silver and gold, so it is not thrown, and this entire impurities is collected at the base of the anode, and it is referred as anode mud. This impurities is referred as anode mud. About 99.99% of the copper metal is obtained by this process, that is electrolytic refining. So this is how we extract copper metal from its minerals. In order to remember this, we can use this flow chart, student. The very first thing, the ore which is taken for the extraction is copper pyrite, that is CuFeS2. This copper pyrite is first concentrated. Since it is sulfide ore, so method of concentration that we are using is what? Flotation process. We are getting concentrated pyrite, and this concentrated pyrite ore is subjected for roasting, where we are getting oxides of copper and iron and copper 1 sulfide. This copper 1 sulfide along with the other component which is called as copper metal is transferred into what? Smelting process, which is giving pure copper 1 sulfide. This pure copper 1 sulfide is subjected for a process of Bessemerization, where there are two things takes place: oxidation of copper 1 sulfide to copper 1 oxide and reduction of copper 1 oxide to copper metal. This impure metal, which is referred as blister copper, is again refined by electrolytic refining, and here we are getting 99.99% pure copper metal. So this is the process how we extract pure copper metal from copper pyrite. So different forms of iron, student, if you will check. So it is like this: cast iron, which is also referred as what? Pig iron. Another form is what? Wrought iron, and third form is what? Steel. So on the basis of the carbon content, these iron are classified into three types: cast iron, pig iron, which is the same thing, wrought iron, and what? Steel. Cast iron or pig iron contains maximum amount of carbon. It is about 4% of carbon. Wrought iron is consisting of the less than 0.2% of carbon, carbon, and the steel contains between 0.2 to 2% of carbon. So the maximum carbon content we can see in case of cast iron or pig iron, and because of this more carbon content, it is hard and brittle in nature. Wrought iron, it contains least percentage of carbon. It is soft in nature, and the steel, it is neither soft nor brittle. The purest form of iron is referred as what? Wrought iron. And the purity is measured in terms of what percentage of carbon. If it contains less percentage of carbon, so it is more pure. So please remember, purest form is what? Wrought iron. And the most impure form of iron is cast iron or pig iron. Now let's talk about the minerals and the ores of irons. Hematite, which is referred as the chief ore of iron metal, student, and the formula is it is Fe2O3. Next is what? Magnetite. This is Fe3O4. Let us compare the formula. Hematite is Fe2O3 and magnetite is Fe3O4. Limonite, if you'll see, it is the hydrated Fe2O3. There is 3 is indicating water of crystallization, and the iron pyrite is what? FeS2. So out of this, there is one more. Siderite. The siderite is what? FeCO3. It's iron carbonate. Out of all these minerals, the minerals from where the iron metal is extracted profitably, that is ore, is what? Hematite. Very first step which involved in the extraction of iron from hematite, as usual, is what? Concentration. Now we all know that the concentration steps involve removal of the gangue particle, that is earthy associated impurities. For this purpose, student, there are various methods, but the method which is used here is what? Hydraulic washing. Now we know that the principle behind hydraulic washing is what? There is a difference of densities between the metal compound and the gangue particle. So through hydraulic washing, we are removing lighter gangue particles, and after this, the second step is what? Extraction. Extraction generally involve conversion of metal to metal oxides and removal of volatile impurities, and that is the reason this involve heating. So conversion of ore, we are converting into what? Oxide, and removal of volatile impurities. So the process that we are using over here is what? Roasting. Now this is done in a type of furnace which is referred as reverberatory furnace, and about 1200 Kelvin. The remaining iron oxide, that is FeO, which is already present into the metal compound, that is ore, during this roasting get oxidized. Since in roasting we are heating it in the excess of air, so once we supply more quantity of air, what happens? This remaining iron oxide gets converted to Fe2O3, and from here we are doing the next step, that is reduction. Now what is the advantage of this process? The remaining FeO oxide gets converted to Fe2O3, and the impurities sulfur and arsenic which is initially present can be removed by forming what? Volatile impurities. So next step is what? Reduction of oxide into what? Metal, and this is done by heating. That's why this process is referred as pyrometallurgy. But this reduction of oxide to metal is obtained by heating. It also involves introduction of some reducing agent, and that is the reason it is also referred as what? Smelting. This smelting or pyrometallurgy, which involve reduction of oxide to metal, is done in a type of special furnace which is referred as blast furnace. So in blast furnace, we are converting metal oxide to iron metal. The metal which is obtained is consisting of what? More percentage of carbon. That's why it is impure metal, which is further refined by a method of liquefaction. If you will check this diagram of furnace, student, this is referred as blast furnace. It's a tall cylindrical steel tower and about 25 meter in height. And if you check this diameter, so this diameter is about 5 to 10 meter. And if you check the inner lining, it is consisting of fire clay bricks, or you can say refractory bricks, which can withstand at very high temperature.
Basically, this is consisting of three parts: hearth, bush and stack. At the top, can you see there are two outlets? The down one is for the removal of molten iron, and just above it there is a outlet for removal of what? Slag. Please remember, the slag is lighter in density, and that's why it can be removed from the upper outlet, and the molten metal which is formed into this is having higher density, can be removed from the lower part of this furnace. Now if you check the range of the temperature, it is around 1700 degrees Celsius to what? 200 degrees Celsius, or you can say 2000 Kelvin to what? 500 Kelvin. At the top, if you will see, there is cup and cone arrangement to introduce the ore, and at the bottom we are finding two outlet. There is one inlet. This inlet is kept for hot air, student. A blast of hot air at about 1000 Kelvin is blown from the downward to upward by layers arrangement. And this temperature range that I told you, it is 2000 to 500 Kelvin. As the charge from the top is added, this hot air is passed through this bottom, and this process takes place simultaneously, and this entire reaction which takes place is to converting metal oxide to metal. This entire furnace is consisting of four zones. One is referred as zone of combustion, zone of reduction, zone of slag formation and zone of fusion. So now we will learn in detail about the functioning of the blast furnace. In extraction of iron in the blast furnace, student, there are certain steps if you will see. The concentrated ore. Now we know that this ore is concentrated by hydraulic process, hydraulic washing. So this concentrated ore of iron oxide is obtained during roasting. So in the blast furnace we are mixing the powdered form of the ore along with the mixture of limestone and coke. This mixture is fed into the blast furnace from its top through cup and cone arrangement, and by selecting reducing agent on the principle of thermodynamics, that is Aluminium diagram, the main reduction steps which involve over here, if you'll see, coke, we are taking powdered form of the coke, so this coke is acting as reducing agent. The FeO which is present into the ore, powdered form of the ore, get reduced by this coke. If it is reducing agent, so it removes oxygen of FeO, if you will see. So it forms Fe, and since the temperature is very high, because carbon monoxide formation favors at very high temperature as per Electrolytic diagram. So at this high temperature, this is the temperature above the melting point of the iron metal. So this iron metal is obtained into what? Liquid form. Here carbon is removing oxygen of iron oxide and converting iron oxide to iron. So carbon is actually reducing iron oxide to iron. So carbon is acting as what? Reducing agent. So we can say that it is carbon reduction process. Now the range of this, if you will see, it's 900 to 1500 Kelvin, student. At higher temperature, how it is obtained? By passing hot air to this mixture. During this, carbon monoxide is formed and it moves to the upper part of the blast furnace, and this carbon monoxide helps to reduce iron oxide. Please remember, oxide of iron is reduced two times. First time it is reduced by coke, that is carbon, and the second type it is reduced by what? Carbon monoxide. So if you will see, Fe2O3 and Fe3O4, it get reduced to what? FeO. This is possible at the lower temperature range of about 500 to 800 Kelvin. This reaction which is involved in this process, if you will see, Fe2O3, which is the ore of iron, it is now reacting into the upper part of carbon monoxide. This carbon monoxide is removing oxygen. It is acting as what? Reducing agent. Can you see this? carbon monoxide gets converted to carbon dioxide at lower temperature. This carbon monoxide reduces Fe3O4 to FeO. Now if you'll see how the impurities are removed. Impurities major which is present is what silica. These impurities are removed as a slag by adding calcium oxide. Student, impurities is silica which is acidic in nature. So we are adding basic flux, and here the basic flux is what? Calcium oxide. This basic flux calcium oxide react with the silica and it forms what? Flux. Calcium oxide is formed by decomposition of calcium carbonate, if you will see. If the calcium carbonate is heated, it produces calcium oxide and carbon dioxide. Carbon dioxide is the waste gas product which is getting removed, and this calcium oxide which is remained or formed into the blast furnace is basic in nature. It will react to form slag with silica. Can you see this? Calcium oxide is a basic flux and the gang which is present is what? Acidic. So calcium oxide is reacting with what? Silica, and it is forming slag which is lighter in density, and it can be removed from the upper layer of the blast furnace. Now if you see this, student, how the reaction taking place at the different regions, let's look at rough arrangement. From this, if you'll see, we are subjecting powdered form of the ore, limestone, that is calcium carbonate, and the coke which is acting as what? Reducing agent. These all powdered form are subjected through cup and cone arrangement, and we fill it at the lower part of this. This all powdered form is heated about 1000 Kelvin from the lower part, where there is a highest temperature. It is referred as zone of combustion. This causes formation of carbon monoxide. See, this is the region where you will find there is the highest range of temperature is present. And as we are moving up into the furnace, the temperature decreases. See, the range of temperature, you can remember, it is around 2170 Kelvin to what? 1070 Kelvin. Now see, all the material, that impurities, the molten slag and the molten metal which is formed, you can see two different layers. The upper layer is consisting of molten slag and the lower layer is consisting of what? Molten iron metal. This two layer is obtained because of the difference into the densities. So molten layer, this slag, it can be taken out from the upper layer, and this is calcium silicate, and the molten metal which is consisting of carbon, impure form of the carbon, it is crude iron which is also referred as pig iron, can be taken out from the lower part. You will see the reaction which takes place onto the upper part, student. The Fe2O3 is reduced by carbon monoxide at the upper part of the furnace, and it forms Fe3O4, and there is a loss of carbon dioxide gas. This Fe3O4 also reduced by carbon monoxide, it forms FeO, and again there is a waste gas which is formed is what? Carbon dioxide. FeO is reduced by carbon monoxide, it forms Fe metal, and the gas which is obtained is what? Carbon monoxide. All the gases which can be released as what? Exhaust gases from this outlet in the form of carbon monoxide and carbon dioxide. At the lower part of this furnace, if you will see the carbon, that is the powdered form of the coke, when it combines with the hot air, it produces what? Carbon dioxide. This FeO which is present in the powdered form of the ore is also reduced by the coke. It forms Fe and carbon monoxide, and this coke is combining with the carbon dioxide and it is forming carbon monoxide. Let us learn again in detail about this blast furnace. I had just given you the rough idea about here. Yes, I have given the very rough idea of the working of the blast furnace, student. Now let us learn in detail about the working of the blast furnace. Now we know that in blast furnace the metal oxide get reduced to molten impure metal through a process of pyrometallurgy, or you can say smelting by using some suitable reducing agent. So the very first thing that we have to understand is what charge. Student, charge is actually mixture of three components. One is what metal compound which is present in the ore. It is mixed with coke. Now you know that coke is one of the allotropic form of the carbon. So it is functioning as what reducing agent. The role of coke is to reduce this metal oxide to metal. And we have also mixed calcium carbonate. So calcium carbonate is going to produce one component, calcium oxide, which is a source of what? Flux. So this mixture of Fe2O3, coke and calcium carbonate is referred as what? Charge. And these components are mixed in the ratio of 12:5:3, where the major component is the metal compound, that is Fe2O3. Coke is acting as reducing agent and calcium carbonate is acting as source of flux. In this blast furnace, there is upper part which is consisting of cup and cone arrangement. Through this cup and cone arrangement, the powdered form of this charge is subjected. At the lower part, if you see, there is inlet which is called as tubers. These are the pipes which are actually supplying what? Hot and compressed air. So once this hot and compressed air subjected inside the lower part of the furnace, it approaches to coke, that is carbon. So immediately it gets combined with the carbon and it forms carbon monoxide, the gaseous product which is formed carbon monoxide, and this reaction takes place at the bottom part of this blast furnace at about temperature of 2000 Kelvin. This temperature is very high, student, and we know that as per thermodynamics or Ellingham diagram, carbon monoxide formation favors at very high temperature. Since carbon monoxide which is formed is a gaseous product, so it moves into the upward part of the blast furnace, and when it approaches to metal compound or when it meets to metal compound onto the upper part, which is one of the component of the chart, it reduces this metal compound to metal. So here the carbon monoxide which is formed at the lower part in the furnace, it moves up, it meets to Fe2O3, it reduces Fe2O3 what? Fe, and there is release of what? Carbon dioxide gas. This reaction takes place onto the upper part of the furnace and it is about 900 Kelvin. Please remember 2000 Kelvin at the lower part, which is considered to be the highest temperature. There is a formation of carbon monoxide, and at 900 Kelvin there is reduction of iron oxide to iron metal, and this reduction is carried out by carbon monoxide. At the middle part, if you will see, Fe2O3 is reduced again, but this reduction is carried out by coke. So onto the upper part, reducing agent is carbon monoxide, and into the middle part or the lower part, the reducing agent is what? Coke. Again, this carbon reduces Fe2O3 into what? Fe. So we can say this metal compound are reduced two times by two different reducing agent. One is coke and another is what? Carbon monoxide. But the reaction which take place at different temperature. Now if you will see, this temperature is higher as compared to the upper part because carbon monoxide formation favors at higher temperature. At about 1200 Kelvin, which is near to the upper part, this limestone powder get decomposed. There is a thermal decomposition of calcium carbonate and it produces calcium oxide and carbon dioxide gas. This calcium oxide is acting as flux, and this flux is combining with the gang which is present into what? Metal compounds. This gang is acidic in nature, and that's why we choose what? Basic flux. So this basic flux combines with the gang and it forms easily fusible mass, that is calcium silicate. It is having lower melting point and lower density as compared to what? Molten metal. So if you'll see, this reaction take place at what, 1600 Kelvin. This part, lower part, which is consisting of the maximum temperature, student, it is referred as zone of combustion. The upper part is referred as what? Zone of reduction, and the middle part is referred as what? Zone of slag formation. So there are three parts: zone of reduction, zone of slag formation, and zone of combustion. You will get the two different liquid layer. One layer, the upper layer, which is lower in density, is what? Slag, that is calcium silicate, and the lower layer is consisting of what? Molten metal. This iron metal is the impure form, and from these two different opposite side, this tapping hole, this outlet, these two can be easily removed. From this we are removing slag, and from here we are removing what? Molten metal. So this is how we are obtaining molten metal into the blast furnace. Now if you will see this, the flow chart, if you want to remember, the hematite, during extraction of iron from the hematite, this hematite is first concentrated by hydraulic washing, and it gives concentrated hematite, that is Fe2O3. The next step is what? Roasting. During this roasting, it gives roasted Fe2O3, which is free from the volatile impurities, and after this it is reduced in the blast furnace to impure iron, which is consisting of around 4% of carbon, which is pig iron. This pig iron is again refined by a process of liquefaction. So this is how the extraction of iron is carried out. This is the following worksheet that you are supposed to solve on the basis of this lecture. The very first, if you'll see, it is match the followings, and the second, it is consisting of true and false. So student, you all can pause this video for 3 to 4 minutes and you just solve it, and after that you can check the answers. Come on, start solving it. Done? Yes. So let us discuss the answer of this. In column 1, they have given reactions involved in the blast furnace, means it is related with the metallurgy of or extraction of iron, and in this column 2 is given what? Temperature. So the very first they have given is hematite ore loses moisture. This reaction takes place at the upper part of the blast furnace, and it requires very low temperature. So the answer for this is what? 500 Kelvin. At 500 Kelvin, hematite ore loses its moisture. Second they have given is what? Reduction of ore by carbon monoxide. So reduction of ore by carbon monoxide, what should be the temperature? Tell me. Yes, it is 900 Kelvin. Third, combustion of coke. This combustion of coke is carried out in what zone of combustion? At the highest temperature, and the highest temperature is what? 2000 Kelvin. And decomposition of limestone, that is done at what? 1200 Kelvin. Let's move to the next one, true and false. The very first, if you'll see, copper matte or copper matte is the purest form of copper. No, it is false, because copper matte is again refined by using the method called electrolytic refining. Second, cryolite, that is sodium aluminium fluoride, and fluorspar, that is calcium fluoride, is added to decrease the conductivity of alumina in Hall's process. No, the statement is false. It increases the conductivity. Third, copper pyrite is concentrated by Froth flotation process. Copper pyrite is actually, it is CuFeS2, it is sulfide ore. So for all sulfide ore, the method of concentration which is used is what? Froth flotation process, and it is a true statement. Blast furnace involve roasting and calcination of hematite. No, it is false. Blast furnace involve removal of gangue in the form of what? Flux, and also reduction of iron oxide. Fifth, you will see carbon and carbon monoxide act as reducing agent in the blast furnace. Yes, it is true statement. Copper is the purified by Bessemerization. No, copper is not purified by Bessemerization. Bessemerization is used for the reduction of copper oxides. And the copper which is obtained after Bessemerization is impure form of copper, which is refined by electrolytic refining. So it is a false statement. Now let us solve the next worksheet, which is consisting of fill in the blank. So we are expecting you to write the correct answers. Please do not copy the question, student. You can pause this video and start writing the answer, and after that, after some time, you can check the answers. So if you see the very first one, the lower part of blast furnace involves zone of combustion. This zone of combustion is the lowermost part, and which is consisting of about 2000 Kelvin. Second, if you see in blast furnace, iron metal oxide, this iron metal oxide is reduced by coke, that is carbon and carbon monoxide. So there are two times reduction take place where two different reducing agent, carbon and carbon monoxide. Third, charge which is added in the blast furnace. Charge is actually a mixture of, this is Fe2O3, that is metal compound, calcium carbonate and coke. In the blast furnace, dash gangue, the gangue is silica. It's a silica which reacts with dash flux, basic flux. The silica is actually acidic gangue and it reacts with the basic flux. It's a basic flux and it gives slag as calcium silicate. The range of temperature of the blast furnace is, it is 1200 Kelvin to 500 Kelvin. Copper matte is consisting of, it is consisting of copper 1 sulfide FeS along with coke and sand. Chief ore of aluminium is bauxite, and the formula of the bauxite is Al2O3.2H2. Copper metal is purified by, the method that we are using for purification of copper is electrolytic refining. Aluminium is refined by dash process. The process which is used is Hoops process and it involves electrorefining. Copper obtained from Bessemer converter is called blister copper. Blister, it's a blister copper. I hope you got the idea of the question, what type of the question is asked here. Now other two worksheet will be given as a homework for you people. This is the another worksheet. So this you will do as a homework. This worksheet 4.3. First, which is the match the following and true and false. And second worksheet is 4.4. If you see this 4.4, this is the worksheet. So these two worksheets are given as about homework.